Well, g'day, Max here again. Another episode, Swarf and Chips. So we'll have a bit of a session in the shed here and continue on with our ball turning attachment. So today what we have to do is get the axis of rotation of the ball turner in line with the centre line axis of the lathe, otherwise you can't turn a proper ball, as I'll point that out later. Before I get into that, I was just rummaging through some old tools that I had the other day and came up with this little gem here. Some smart, well, it came with some tooling I got over from the US. Some smart cookie, it's very basic when you look at it, has come up with this. So, the Woodruff keyway cutter. This is a Pratt & Whitney, Hartford, Connecticut. And this other Woodruff keyway cutter, or what was a keyway cutter, I don't know what brand that is, Super Speed. So what they've done, or what you can do, if you damage a Woodruff cutter, so you might break one of the teeth off or something, okay, what this guy's done with this one is ground the end down to make it into a grooving tool. So if you compare them both, you can see exactly what's happened. Quite an easy grooving tool, good idea. So it's a piece of useless information, so don't throw away your damaged Woodruff cutters. Now the other piece of tooling which I got was this is a multi-fix tool holder. I'm sure a lot of you are familiar with. Now, what's I'm not sure about, because I'm not that familiar with multi-fix. I mean, I grew up with the Dixon piston type, as is what I've got on here. Well, that's an imitation Dixon, that one. This is made in Switzerland. The numbers on it are CD40170. So, I haven't got a rule scale. So this one measures, what are we, inch and 5/8 by 6 3/16 long. So you can run an 1.5 inch square shank tool on this. So what I'm interested to know, what model multi-fix tool holder would this have come off? What's, and being that this is made in Switzerland, is this a genuine, where is multi-fix made? I don't know. So if anyone could comment or help us out on that one, would be greatly appreciated. So, but anyway, let's swing you around and we'll get this ball turner set up so we can establish the centre line axis, true to the centre line axis of the lathe. We'll bring you down. Okay, so what we plan to achieve is we have our base plate for the ball turner, which references off the V groove. So then the other part of the base assembly, as previously explained, goes on here. So what we've got to reference today is the centre of where the ball turner rotates. The centre axis where this pivots, we have to get that dead in line with the vertical centre axis of the lathe. Otherwise, what will happen when you go to turn your ball, you'll be machining a ball around, and if your centre line is too far this way, you'll machine a dimple into the end of the ball. And likewise, if your centre distance is too far the other way, your machine a ball, it'll look like a cone head. It'll have a slightly pointy shape on the end of it. So we'll get this set up. How we're going to do it is we'll put a piece of stock in the lathe chuck, and I'll mount an indicator down here, and we'll true it up that way. I was just thinking just before, when I changed the chuck over, because I had the 4-jaw on this just before, and I put the 3-jaw on for this exercise, I'll just show you something with the reference marks on these cam locks. I mean, most of you will know about them, but there may be 1 or 2 people have little lathes at home in their sheds. They're not necessarily trade qualified machinists, so they might not know about this little thing on the cam lock spindles here. So we'll just give you a quick look. Okay, these are the reference marks on the cam lock spindle assembly. Sorry if the camera's a bit shaky, I'm holding it by hand. Okay, so you have your cam, and it has this reference line here. On your spindle you have this line, straight line here, a V and another V down here. So when this line on your cam is in alignment with this one, it puts the cam at its release position. And when you mount your chuck onto the spindle, you tighten your cam down. This line here must fall between this V and this V. If when you tighten it up, that line just falls just outside that V, it hasn't quite got a secure grip on the stud on the rear of the chuck. And likewise, if it comes the other side of this V, the same thing, it hasn't got a secure grip. So if you are on this side, it means the stud that engages into this particular cam will have to be unscrewed 1 turn, and if you're on the other side of this V, the stud will have to be screwed in to the backing plate 1 turn. So we'll swing you over to the backing plate and we'll give you an explanation of that. Okay, so this is the rear of the cam block. So this scalloped out area is where the cams locate into. And what you can do, these pins are loose, they're actually threaded into the back of the chuck. Now, to adjust it, you remove this cap screw and then you rotate these. Because they're threaded, you can turn them in, or unscrew them a turn, or screw them in. So you just unscrew them or screw them in whichever way you need, 1 turn at a time, and then remount on the spindle, and then check the alignment marks on those V's on the spindle. So just another piece of information. Anyway, we'll move on. Okay, the other thing too, I have these reference marks which I've centre popped in on the nose of the machine and on the backing plate. It just makes things easier when you're setting up your cams. Everything goes back in the same situation. So I've one on this chuck and my 4-jaw as well. Okay, we'll get our setup happening for the centralisation. What I didn't mention before, this tool holder, this multi-fix tool holder, this is off the lathe I've just purchased. So it's a 21-inch swing lathe, so it's a bit bigger than this little girl here. So, okay, we'll get a piece of material chucked up in the lathe so we can make the test bar we'll need for indicating the base plate. So we'll get this out of the way. Just chuck a bit of oil on the ways. I just use any thin type hydraulic oil, 32, whatever I can get. Thin oil is good oil. We'll just bring you in a tad closer. So what we're going to do is machine a radius just by hand on the end of this bit of bar. The grade of steel is HNW, which is who knows what, could be anything. Okay, here we go. Before we do that, we'll just slow our feed down a bit. Okay. Okay, there's a simple radius we've machined on the end of our part there. So what we do now is we'll take the tool out. We'll set up our base plate again. Now what we'll do, because this base plate started life as a rotary table, we'll put the table component back into it. Bring you back out so you can see a bit better. Mount the dial indicator. Up onto this We'll get the indicator set up and we'll bring you back. Okay, well this is our setup. We've got a dial indicator mounted on the rotary table. So with the last word starret, that indicator will sweep side to side of the test bar we have. And we have another indicator set up over the back to sweep the rear of the rotary table base, so we keep that square to the main base of the radius tool. So I've got two parallel clamps on either side to hold the rotary table base down, and then I've just tapped it left, right, in or out just so we can get some alignment. So first one we had, so we have an indicator here set up to indicate the rear of the rotary table base. So we'll just get that back on 0. So we've squared off the rear of the rotary table base. So we're good that way. Okay, so now we'll get that out of the way. Now we have to sweep the test bar with the starret last word. Okay, now what we're doing, we're looking for the low spot, so we're sweeping in an arc. So we can bring you in a bit. We sweep our arc, we got it right on 0. There's the low spot before it goes either side of the arc and starts rising up again. Okay, so then we get our base, we slide our base, swap hands here, you see. Slide our base out of the way, and we come round 180 degrees on the rotary table. As I said, it's hard to hold this iPad and film this. Okay, we slide our base back in the other side. Okay, now we do the same thing again. We sweep the base to find the low spot. And we're about we're within half a thou. It's hard to stay out of the shadows and get the light right. Okay, so that tells us that we are centralised from one side to the other. The axis of the rotary table is dead in line within half a thou of the vertical axis of the lathe. So what we'll do now is we'll nip these clamps down, we'll slide this back, and we have to drill and dowel this area here and diagonally across this area here. That'll keep a permanent location and fixture for the rotary table base onto the major base. Now the reason I want it dowelled is I want to be able to remove this, and for a later project I want to put an extension out here so I can mount the radius tool out further and able to machine a radius like on something like a hand wheel as well. I don't want it limited just to ball turning. So now we're going to clamp down, we'll get her in the, set up in the drill, we'll drill some holes. Okay, so we're set up in the vise, ready to drill our dowel holes, but as life would have it, the drill bits I've got a couple of thou bigger than the dowels that I've got, so I want to keep it a neat fit, so I'll show you a little trick. Okay, what you can do, it does work sometimes, works to an extent. If you've got to drill an accurate size hole for a dowel and you don't have the right drill bit, because the drill bit will sometimes drill a little bit oversized, which is what they like to do, and you don't have a reamer, what I've got away with in the past, and it has worked, is if you get your drill bit, this obviously I'm just not going to use this for my dowel, it's for an example. Okay, if you see that angle, that sharp point just there on your drill bit, well, if you grind that to a radius, a very slight radius, just so it takes away that sharp edge there, or that sharp corner there, that will assist in the drill cutting closer to size. Now, also on my drill bit, the lands here, this edge here, I'm just going to give that a very slight touch on the grinder just to reduce that diameter. And I mean, of course, we're only speaking a drill bit like that, 532. So we just got to reduce the diameter down a couple of thou, which should be spot on for our dowel holes. Okay, we're over at the grinder. Just give it a touch up first. Doesn't need much. Then we'll do the radius on the corner, just very gently. Then we'll take a bit off the land. Over it. $52, $153, and our dowel is 154. It's difficult to measure. Take a bit more off, give it a bit more clearance behind those radiuses. Okay, we'll give that a shot. Okay, so before we modified our drill bit, we did a test hole with the standard 532 drill. It's quite wobbly. You know, there's a bit of play in there. Did 2 holes. Tried the next size down, which wasn't going to go anywhere. So we had to take that play out. So we've got our modified drill now. So we'll drill another test hole and see if we've reduced the diameter of the hole we're going to get. Plenty of cutting oil on it. We want to give it every fighting chance. Okay. So that's our old hole with the original drill. Get a bit closer. There's a bit of play in it. How can I get this? A bit hard to see. Okay, that slips in all these original holes quite easy. That was the one with the undersized drill. And here we are with our new, it's that one there, test hole. So that should, well, that'll tap in there nicely. I don't want to tap it in here because I won't get the damn thing back out. So what I can do now is I can go ahead, we can drill our holes through here. We know we're going to have a tight fitting dowel. Just get no particular location as long as it's in a reasonable looking spot. That'll be fine just there. We've gone through the cast iron of the dividing head base, so into the steel now. We want to set a depth. I think we'll go 10 millimetres, 3/8 of an inch into the major base. Okay, that's that one. After we've drilled the other side, what we'll do is we'll re-drill, we'll separate the rotating component base off the major base, and we'll just ease the holes out in the top further up the drill bit where the shank hasn't, or the diameter hasn't been reduced, and that'll just give us a nice neat sliding fit over the dowel for this, and a press fit for the dowel for this. So, get the other hole done. And this just goes to show that, you know, for doweling jobs in the home shop, you don't want to go and buy a lot of expensive reamers and different sorts of drills and all that. This is just another way to get it done with using what you've got in the shop. Old school tricks to modify drill bits and so on and so forth, just to get the job happening, and it works. People have been doing this for years. So we're through the cast. Now we're going to turn to the steel, so we're going to cut and oil. I just use cutting oil. I use for the lathe and the mill for the coolant. It's just neat, without water mixed into it. Castrol clear edge. I am considering switching to synthetic. This is a little way off yet. Move our dowel before we lose it. Okay, look at that, it's a beautiful fit. Look at that, it's just pushed down. Look at that. That is... Oh, that's magic. There's absolutely no play on that at all. Okay, we can take our clamps off now. Look at that, that's beautiful. Look at that. There's absolutely no play whatsoever in that. Nice sliding neat fit. So I thought I may have to go through and open it up a bit, but not the case. They don't even fall out. An even tighter fit. Oh, can't get that out. Where they go into the steel. That's a tap and fit, that, and a very neat sliding fit on there. So that's what we call in the industry the dog's bollocks. Okay, well, we'll get our dowels tapped in. Good, there you go, nowhere. Test fit our base. That is perfect. So we're all doweled in position. Absolutely no play, so she'll fit back on, perfect location every time. So as we said before, our next operation is to machine up the clamping cross plate for underneath, which will be the same as what's on the tail stock, and then we'll proceed with the tool holder after that. So we'll bring you back.